Good morning, my name is Sonia Martel. I am the leader of the Sustainability Research line at ICRAM, University of Burgos, and today I'm going to present you the sustainability and safety aspects in the green chemistry. Today's agenda, I'm going to do a brief introduction to the topic, then I will speak about the regulatory efforts and opportunities, then we will describe the SSBD framework, the Safe and Sustainable by Design framework. I will speak also about the building blocks and the iterative process of this framework, and then we will discuss the challenges and opportunities. For the introduction, the chemical industry, as you know, keeps growing and developing new materials to support a more sustainable and efficient economy. The main drivers are the decarbonization, smart materials, the energy transition, and digitalization. They all depend on chemistry and innovation. Today, more than 350,000 chemicals are registered worldwide, and around 1,700 ones appear yearly. However, we often lack enough information about their safety and their environmental impact. Let's see a little bit the regulatory efforts and the opportunities for the chemical industry. The European Union is developing multiple regulatory and funding initiatives. Some of the key policies that directly or indirectly affect the chemical industry include the climate law, the European Climate Law, the Circular Economy Action Plan, the Critical Raw Materials Act, and more in particular, the Chemical Strategy for Sustainability. In the Research and Innovation Program, Horizon Europe, this funding program includes the safety and sustainability of chemicals in a transversal way across different clusters, the cluster 4, 5, and 6, which are the digitalization, industry and space, climate, energy and mobility, and also food, bioeconomy, and environment. The clusters include different funding opportunities which are related with the safety and sustainability of chemicals. Within this policy landscape, in 2022, the first version of the Safe and Sustainable by Design framework was launched. The goal of this framework is to harmonize the way we assess chemicals and materials, ensuring they are safe, sustainable, and fit for purpose before entering into the market. The SSBD framework, Safe and Sustainable by Design, provides a common approach to support innovation in chemicals and materials, while they ensure safety and sustainability from the early design stages. It is an iterative process that integrates safety, environmental, and socioeconomic aspects throughout all the design and the development cycle. The framework includes several assessment areas. It includes intrinsic safety and functionality, also human health and environmental safety, and finally the sustainability dimensions, including environmental but also socioeconomic aspects. The ultimate goal is to support responsible innovation and to help developers to identify safer and more sustainable design choices before a substance reaches the market. One of the key elements is the environmental sustainability, is the one I'm going to discuss a little bit now. Within the SSBD framework, the environmental sustainability assessment aims to evaluate the potential environmental impacts of a chemical, material, or product throughout its entire life cycle, from raw materials to the end of life. The main tool used for this evaluation is the Life Cycle Assessment, LCA, following the ISO 14040 and 14044 standards. In practice, data availability can be a challenge, especially for early-stage substances. Therefore, simplified models based on LCA, digital tools, and predictive approaches can be used to estimate impacts and guide design decisions. Through LCA, we can quantify and compare different impact categories, such as climate change, resource use, air, water, and soil emissions, ecotoxicity and human toxicity, and also waste generation and end-of-life management. This is the stage that we call life cycle impact assessment. The European Commission recommends the use of 16 indicators described in the product environmental footprint method. The ultimate goal is not only to identify the hotspots, but also to support design improvements. For example, selecting alternative feedstocks, reducing energy intensity, or improving recyclability. Finally, the environmental assessment results will be integrated with the socioeconomic aspects, and they will also be integrated with the safety and functionality previous assessments to determine whether the new material can truly be considered safe and sustainable by design. The challenges and next steps. Finally, we will speak about the challenges of the SSBD framework. Implementing it in practice still faces several challenges, especially when assessing environmental sustainability at early design stages. The main include limited data availability, as we were discussing before, the methodological complexity. Aligning environmental, safety, social, and economic assessment requires harmonizing indicators and metrics. Also, the trade-offs between impacts, because sometimes a solution that maybe reduce the carbon footprint may increase water use or reduce depletion, or maybe it is not the safest one. And also the scalability and comparability of the results. Despite these challenges, there are promising perspectives and opportunities. The use of digital tools and databases, also artificial intelligence-based models to fill data gaps can support this method. Also, the integration with circular economy principles promoting designs for reuse, recycling, and reduced waste. The development of sector-specific guidance can also support different sectors and support the industry development. So these developments will make the SSBD framework more practical, transparent, and impactful, and will make it more helpful to support safe and sustainable innovation. All these efforts move in the same direction, making sustainability an integral part of innovation, not only an afterthought. So, as a wrap-up, the Safe and Sustainable by Design framework represents a new mindset for chemical and material innovation in Europe. It encourages us to think beyond performance and functionality and to integrate safety, sustainability, and circularity right from the design phase. The environmental sustainability assessment plays a crucial role in this process because it helps identify potential impacts early, supports better decision choices, and ensures that innovation contributes to a climate-neutral and resource-efficient economy. Combining scientific assessment, digital tools, collaboration across sectors, the SSBD becomes not only a policy framework but also a strategic driver for responsible innovation. And this was all from my side. Thank you very much for your attention, and I encourage you to keep watching the next videos of this MOOC.